Great. Well, thanks very much. And just before I get started, I wanted to advertise if anyone's keen. I have little paper models of the JCMT. You can make your own. You have a separate rotating like telescope and dome and stuff. So pick up one, and if I run out, there's a website where you can just print out your own. So good fun for the end of the meeting. So just to start off, we've heard a little bit about this already. I just want to say two things, I guess. First, thank you to several people who sent me lots of great material, which is going to be throughout this talk, and I've had to chop it down quite a bit to fit in 12 minutes. And as I'll allude to a little bit, the history of JCMT, especially at the beginning, was quite a challenge for the community, and I'm going to gloss over a lot of that. You can chip in your stories at the end, but please be nice about it. Okay, so starting off, I wanted to start with the story a little bit before Canada actually got involved in the JCMT, because this is a really great story, and this one I'm just going to read to you. So this is from Richard Hills, and it's in the JCMT newsletter when they're doing recollections of early days, and so they're talking about the steel that was used for the enclosure of the dome. And so they got the steel made pretty quickly, and then shipping it to Hawaii was where things got interesting. So the large boat that was supposed to scheduled to take it broke down, so the shipping company subcontracted it to a small freighter, which was supposed to take it directly to Hilo. We were already somewhat alarmed when pictures of it setting off showed that the boat was barely visible under the large pile of steel lashed to the deck. After several weeks had passed with no word, investigations revealed that the boat had actually gone to Holland and loaded up with an additional cargo of high explosives. This meant that there was a delay before it could get through the Panama Canal. Presumably they have special days for dangerous cargoes. It then disappeared again, no doubt to offload the explosives somewhere on the Pacific coast. By the time it reached Hawaii, the penalty clauses for late delivery were nearly equal to the total fee for the charter, and the captain stopped outside the territorial waters and demanded full payment of the original price, or he would offload the steel into the sea. It seems he did not understand the law of the sea, because we were able to obtain a writ for piracy on the high seas, and the U.S. Coast Guard went down and nailed it to the mast. They took possession of the boat and towed it into Hawaii. So, interesting beginnings, but at least you can see it did eventually arrive. And there's the steelwork, and then there a few years later, apparently it was quite a complicated operation trying to get the framework of the dish into the dome. They had to be rotating the dome at the same time as they were lowering the dish. So it was quite interesting early days. This was all before Canada actually got involved. So we've already heard quite a lot. I won't read out any of this, but we've heard about how there was these budget cuts and all of a sudden a decision to first hold the decision to resurface the ARO, and then eventually the decision to cancel that and join the JCMT instead. One thing that hasn't really been mentioned yet, and part of the controversy, is that it seems like this committee that was struck to recommend whether they should continue with the ARO or move into JCMT was very much divided between the university and NRC communities. So I gather that made things a lot more challenging in the years that followed. But Ernie Sequist said that the committee itself was actually done very nicely. So thank you, Chris Purton. He was quite impressed with how you had led a very difficult committee. All right, moving on. So, so that's the signing committee when Canada did eventually get involved in the JCMT, and that's a little cartoon from the ARO newsletter talking about how we were getting out of ARO. A few months before we actually signed this agreement, Lewis found this fantastic confidential fax to Don Morton from several months earlier, and this was sent out by the Brits trying to figuring out what they should do with the institution that eventually became the Joint Astronomy Centre, so the institution that was running both UCURT and the JCMT. And the name was originally the United Kingdom Telescopes, and by this point the Dutch had already joined in this organization. They say this name is already embarrassment because of our Dutch colleagues, which will become even more acute if we are joined by collaborators from other countries. Canadian involvement in the JCMT could be announced in as little as 3 months, and in fact it was 2 months from when this fax was sent. So they were clearly thinking about what to do about that. And this fax goes on for 3 whole pages talking about different possibilities for the name. The one that they were suggesting was a Kaiulani Imro Observatory, so combining a famous native Hawaiian person with just talking about it being an infrared facility. They were a little bit concerned that it wasn't a curse word in some other language they didn't know about. But apparently the European staff didn't like that name very much, and so they go through a number of other suggestions, such as the James Cook Observatory, and they decide that all of those would be highly insulting to the local Hawaiians, so that's a problem. The Joint Astronomy Center name did not come up at all in this document, so I'm not sure when they came across that, or if it made it in time for the dedication ceremony in April. I haven't seen any documentation on what the facility was called at that point. But anyway, everything eventually went forward. I'm skipping over a lot here, but Canadians were posted to JCMT. We started quite heavily on helping with astronomy support and also helping with instrumentation development. And so this is the first instrument that Canada sent to the JCMT. It's the Canadian Acousto-Optic Spectrometer, and this was adapted from an instrument that was supposed to go on the ARO. I gather it had a few problems. It didn't work too well, and it also didn't have a lot of time to really get debugged. The Dutch sent in their DAS system very shortly thereafter, and it replaced this first instrument. However, after that, we started having a lot more success. So in 1991, the instrument group developed the receiver B3I, and you can see there's the receiver, and that's the technical team, and the commissioning team waiting for first light. And this was a huge success. So John McLeod was telling me that while this was being developed, there was a parallel effort going on in the UK. And the one that HIA was developing was really sensitive using new technology. So they're getting 150 Kelvin noise. At the same time, the Brits were only able to get down to 600 Kelvin noise. And so they eventually just gave up on their efforts because it clearly was not going to be useful. And ours went ahead and got installed and started doing great stuff. And just to show that the engineers weren't always hard at work, they had a bit of time for fun as well, so thank you, Bob, for this wonderful picture. So this is some of the engineering team, and they're showing off their rivalry with CSO. Shortly after receiver B3I was put on the telescope, Joseph Fletcher sent me some interesting stuff about his adventures there. I'm not going to go into this in too much detail. He sent me lots of really interesting documents, but let's just say even before he arrived, it was known that there was electrical problems at JCMT, but he did a really thorough job showing just how many problems there were. So he spent 9 months figuring out exactly everything that was wrong. Big, long report. Just a few little tidbits from here that are kind of interesting. So the ground current was, there was a current running through ground, and it was quite a large one, which you really don't want. Other highlights, I particularly like this one. I found this water-soaked box. I'm told that this is the source of the UPS power for both the fire alarm system and the telephone. This is not a good idea. We need to do something about this. And all sorts of other things. The list went on and on. But really, as a testament to his hard work, after being there for a few years, he fixed everything. And they didn't even lose observing time. They got, every night they were on the sky, and during the day they just fixed the problems one at a time. So well done and thank you. Oh my goodness. Okay, go faster. Whoops. All right, so right after this, the group gets hit with being told that they're going to have to move from Ottawa to Victoria. So this is a group photo just from before the move. Receiver B3 was in progress at this point, and so the group had to actually finish developing this new upgrade for the original B3I while they're moving from Ottawa to Victoria, and they did a great job. They actually got an award for managing to finish the project while they were doing the move, and this instrument worked very well. And in fact, it worked so well that immediately, and I should say also that B3I was still working really well, the one that got retired, and so there was immediately plans to convert B3I to receiver A3I. And they finished that in record time, a little less than 2 years to get that one going. And you can see here's a picture from the first light of that one. And what's really neat, that piece of paper they're holding is this. We actually have the original. It's a signed spectrum of the first light. So that's pretty exciting. I want to switch for a minute out of to an instrument that wasn't actually developed by HIA people just to talk about Scuba. This was a really revolutionary continuum instrument. And lots of delays, lots of other challenges, but once it actually got working on the telescope, it did really amazing things, and Scuba was in fact the second highest cited instrument anywhere in the world in 1999, second only to Hubble, so that's pretty impressive. And you can see they were very excited when it actually finally did arrive after a long delay. And I'll just say this is also about when I hopped into the JCMT scene. So this is a picture from my first observing run back in 2004 with my supervisor, Doug Johnstone. And what was kind of strange is that Scuba has been retired. It's now in the National Museum in Scotland. I'm sort of surprised that an instrument that I've used is already in a museum. That feels a little strange. But there you go, 2 minutes. Okay, I will skip this one and just say I have some great observing stories that involve duct tape and C-clamps, so talk to me later if you want to find out about those. Moving along, in the mid-2000s, there was a plan for refurbishing all the instruments on the telescope, so creating a new continuum detector, new heterodyne receivers, and so there's a plan for having these large legacy surveys. So like Tom was saying, surveys really are the way to go these days, and so there were 6 or 7 surveys approved. I'm really interested in the nearby star-forming regions one. And so these were all planned, and then we got hit with a series of delays with the instruments actually arriving. So there was the HARP receiver to replace receiver B, and so this is a 16-pixel array. And we didn't, HIA didn't work on the HARP part, but we did work on the Axis backend, and as far as I know, that all went on time, on schedule, working perfectly. HARP itself was delayed for a little while. Scuba 2 was very ambitious, and it got quite delayed. One of the delays was kind of beyond their control. The detectors were being tested out in NIST, and somewhere else in the building, a vial of plutonium on the floor and contaminated the entire building. So no one was allowed in the building for 6 months while they decontaminated. So that was a bit of a delay in actually getting to touch.
In the same room.
Was it in the same room? I didn't know that. Okay, I didn't realize that. I thought it was somewhere else in the building. It had nothing to do with their detectors. It was just something else in NIST. Bad luck. And then I should also say there were 2 other Canadian contributions planned, a next generation polarimeter and FTS, developed at Montreal and Lethbridge. Unfortunately, these plugged in through Scuba 2, so they couldn't be commissioned until Scuba 2 was up and running, and timing just meant that was not going to happen for this round of legacy surveys. Pol 2 is now just finished being commissioned and it's actually working on the telescope, and the FTS2 seems to be mostly working, but it's not yet offered for observing. And I really want to point out, it's kind of amazing, receiver A3, which is the old receiver B3I that got refurbished, so it's back from 1991 when it got made, it's still on the telescope, it still works. So way to go, engineers, this is awesome. So as has already been alluded to, JCMT has undergone a bit more of a transformation recently. So the old model operating by the Brits and the Dutch and the Canadians ended. Brit and Canadian support ended in 2015, and the last photons were actually for the Gold Belt survey that I'm a part of. They were looking at this rather boring star-forming region, but still exciting. We got the last data out of the telescope on the old model. There's the Canadian team that was doing it. And presently, there's an East Asian consortium that has taken over running the telescope. They've developed a new suite of legacy surveys that Canadians are still allowed to be involved in, and we have a limited amount of PI time. And I should say that we've left the telescope in a really good state for whoever the current and future owners are. There's 3 very well-functioning instruments, and the polarimeter is starting to work, so it's really an exciting time to be on the telescope. So thank you.
Questions for Helen? Yes.
What was the plutonium going to be used for?
It had nothing to do with Scuba 2. I have no idea. It was just some other experiment that was in the same building, or I guess in the same room as it turns out, but not related.
Bill.
This is just a background comment. I was
Sure.
on the JCMT board
Ah.
in Stormwater for the first 2 years when Canada joined.
Uh-huh.
And there was a lot of tug of war going on between us, or among us, the Dutch and the British, on how the development fund should be routed to
Mm-hmm.
development groups. And Scuba was a huge gobbler of funds, government
Yes.
funds. And there was a lot of opposition to funding Scuba at the £400,000 a year or whatever it was level.
Mhm.
And I remember on the board, the people who wanted Scuba to succeed prevailed in the end, but it was after a lot of discussion.
Right. Well, I gather it was way over time, way over budget. I mean, in the end, it was a success story, but it was quite a rocky road to get there.
And some of the competitors for the money were us, because the Scuba was, of course, the Edinburgh
Right.
lab.
Mm-hmm.
Saw some other hands back there. Yes, Tony?
Yeah, I'll just mention that Gary Hubby did get an NRC Outstanding Achievement Award for the Axis project.
Oh, excellent. Sorry, I should have
And,
included that.
and well deserved it, because I think he was probably, from his viewpoint, like herding the proverbial cats along. And he survived the experience.
Great.
Questions, comments? We have time for one or two. All right. Well, thank you, Helen. Really
Thank you.
appreciate it.